Well, today on Why Bother Math, we're going to look at a certain problem. It's one specific problem, number 105, on the SHSAT sample test. And looking at that problem here, see if we get a good view of it. So they're giving us 10 over 13 as the repeating decimal, which is there. And in the infinitely repeating decimal above, 7 is the first digit in the repeating pattern, which you can see with your own eyes. What is the 391st digit? 391st digit? They give us a number of options. Well, let's just see what they mean. First of all, you might be wondering, maybe you know, but you might be wondering, what is this bar over the digits? Well, that means it's a repeating pattern. So, for example, we've all seen 1/3. I'm going to do this on another piece of paper. 1/3 equals 0.333 ... Another way of writing that is 0.333 bar. Means the same thing. You can make it even simpler, 0.3 bar. Now, another example. This is 1/6 is half that, so it's 0.16666 ... Now, if you're just looking at this, you wouldn't really know, like, is the 1 repeated? Is this 16666, then 16666, or is it just 16666? Well, if you use this notation, 1.16 bar, then you know. Then it's 0.1666666. Now, these two examples that we have here, there's a repeated pattern of one digit. For other problems, there can be repeated decimals which are more than one digit. So let's give an example of that. 1/11 equals 0.09090909 ... Now, that could be confusing again with the ... How do you know that that's 09 ... How do you know that the 09 is repeating? Maybe the whole thing repeats. Maybe just the 9 repeats. So, just to be clear, the standard way of writing that is 0.09 bar. That makes it 100% clear. Okay, so now let's get back to this problem here. They're asking us, quite simply, what is the 391st digit? Now, we could write this out repeatedly, right? We know what it is. This is 0.76922376930, and so on. We could keep going, and we could keep going to the 391st digit. That's going to take all day, and we're going to make a lot of mistakes. So what's the other option here? Well, the other option is to note that this pattern repeats every 6 digits. See if I've got that right? Yes, every 6 digits. So, for instance, the 391st digit that's going to be the same as the, 385th digit, right? Which is the same as what? The 379th digit, just taking 6 down. Well, what can we do to simplify this process then? Because we could keep going again until we get some digit, like the 3rd digit or 4th digit or whatever, within the range that we can see them. Well, the obvious thing is that this is an example of an application of a remainder, a division remainder. So let's say I take 391 and I divide it by 6. Okay, now this is fairly easy, right? 6 here minus 36 is 1, and then 5 minus 30 is 1, remainder 1, or 65 and 1/6. So so let's see what that means. The 391st digit, I think, is going to be 7. It's going to be this first one here. Why do I think that? I think that we will have this pattern repeated 65 times, followed by the next digit. Well, let's just check our work, right? So this pattern is 6 digits long, and we're repeating it 65 times. And that takes up the first 390 digits. Then the next digit is the one we're talking about, the 391st digit. So the answer should be 7. And that is, in fact, one of the answers here. So I think it's D. Thanks for watching.